Hi, good evening everyone. We are going to solve the multiple choice question from unit number 3, magnetism. The question number is 7. Okay, the physics chapter of unit number 3, the multiple choice question number 7. We are going to find out the solution for the particular question. Okay, so this is the problem actually. Two identical coils, each with the n turns and radius r, are placed coaxially at a distance r as shown in this diagram. Okay, if I is the current passing through the loops in the same direction, then the magnetic field at a point P at a distance of r by 2 from the center of each coil is. See what they are asking, if the current is flowing through this coil which is having n turn here. So this is the coil is having n turn and the radius is r. Okay, and they are placed coaxially. Coaxially means this is the axis line, so they are the same the level, the axis is in the same level coaxially at a distance r. Okay, and the distance between these two coils is also r, and the radius of the coil is also r. Okay, as shown in this diagram. If I is the current, so current is flowing through the coil, both the coils, okay, through this loops in the same direction. So the current is flowing the same direction. Then the magnetic field at the point P. So what they are asking to find out what is the magnetic field here at this point. What is the magnetic field, which is this point is exactly at the middle of these two coils. So that means what, this distance will be equal to r by 2. That one you have to understand. So this is r by 2. So that's given in the problem itself. The distance of r by 2 from the center of each coil. So they are asking to find out the magnetic field at this particular point P. See, for this you know this particular expression, okay, where we have derived already. So this is the if I am having one coil, okay, one turn of coil, so it is having a center and it is having a radius of r, okay, and from the center of this coil a point is there, say point P, okay, and this distance of this particular point is z. Okay, then what is the magnetic field available at this particular point P is B vector. Okay, so that B vector, okay, that B vector only we know this particular formula, okay, that is mu naught I by 2. So mu naught you know that is a constant, actually permeability constant for this particular medium, and this I is the current flowing through the coil. So this is the current flowing through this coil, and r square, okay, r square divided by r square plus z square whole power 3 by 2. So this is actually the formula to find out the magnetic field at this particular point when it is situated like this at a distance of z. So in our case we are having n turns here, so I have to multiply this expression by n, okay, because I am having more than one coil, so n turns are there, and how many coils are there is two sets of coils. So this is one, okay, this one is another one is 2, so there are two coils here, so I have to multiply by 2. So what happens, this 2 and this 2 will cancel, and this z only is nothing but r by 2. Okay, this is my z. So instead of z I have to substitute r by 2. So now what will happen to this expression will be mu naught n I, okay, mu naught n I into r square divided by r square plus, instead of z I have to substitute r by 2. So this is whole square. So this one is whole power, which is raised to 3 by 2. Okay, so we have to simplify this. When I simplify this expression, you will get the answer. Okay, that is going to be your answer. So here I can substitute like this, that is, can simplify like this. So r square divided by this r by 2 whole square will become this 4. Okay, so here we have, instead of this 4 I am writing it as 2 square. Okay, so 2 square, and this one will become 4r square plus r square. Okay, and this one is whole power 3 by 2. So this is the final expression here. So now what happens, this one is 4r square plus 5 plus r square will become 5r square. Okay, so mu naught ni r square divided by 5r square. Okay, and whole power 3 by 2 divided by 2 square whole power 3 by 2. What will happen, this 2 and this 2 will cancel, so 2 power 3 will go to the numerator. So finally this equation will become mu naught ni, this 2 cube will become 8, yeah, so it become 8 mu naught ni, okay, into r square divided by this 5r square whole power 3 by 2. So this square, this 2 and this 2 will get cancelled for r square. This 5 will become 5 power 3 by 2, and this r square power 3 by 2 will become r cube. So this r square and this r cube will get cancelled by r. So this is going to be equal to 8 mu naught ni. Okay, 8 mu naught ni divided by 5 3 by 2 r. So this is going to be the final answer. This is going to be your answer now. So if you check it, this is the answer. So B is your answer. Okay, this is how you have to solve this particular problem. But you can also do some wild guess, because this is the only, the 4 option, this is the only option which is having 5 power 3 by 2. Okay, that is 5 power 3 by 2. That option also we can we can have some wild guess at this step itself. Okay, this step itself, because r square plus r by 2 whole square, so the denominator will have this 4. If I take this as a LCM as a 4, then this 4 r square plus r square will become 5r square. So in that way also I can do some wild guess here. So anyway, you have to solve this particular problem within a very short time. Okay, we'll see you in the next video. Thank you.